Okay, so these are one of let me just say this topic is one of the easiest in mathematics, but I don't know why a lot of students find it confusing. So I'll try to make it as easy as possible by separating these things first. So this is typical of paper 1, by the way. Write down the following ratios. So on this one, we want the ratio of BE to CD, where triangle ABE is similar to triangle ACD. So this is how you do it. Just separate the two triangles which are similar, like this. Forgive my drawings. I'm trying to make the video as short as I can possibly make it. So this is 2 centimeters, this is 1 centimeter. 1 centimeter, 2 centimeters. And then this one here, AC, is the distance from A to C. So it's not a 3. 3 is the distance from here to there. Remember, we also have another distance from here to there. So if the distance from here to there is 3 centimeters and the distance from here to there is 1 centimeter, then the total distance AC will be the sum of these two, 3 plus 1. So this one will be 4 centimeters. This one is unknown. So now we want to find the ratio of BE to CD. So now, when two triangles are similar, it means all the sides are in proportion, or maybe the ratios of each pair of corresponding sides are the same. So this one corresponds to this, this one corresponds to this, this one corresponds to that. So if the ratio of right now we are trying to find the ratio of BE to CD, which is the ratio of the smaller triangle to the bigger triangle. Just get any of the sides which have numbers, any of the corresponding sides which have numbers. Like you have AB to AC. So AB to AC. There, this is 1 to 4. That is 1 to 4. So if this ratio is 1 to 4, then the ratio of BE to CD is also 1 to 4. And the ratio of AE to AD is equally 1 to 4. So that means this ratio here is 1 to 4. It's that easy. Let's look at the next one. We have this one here. We are trying to find the ratio of, I didn't indicate here, but it's DE, this one, to AB. So now, to find this ratio, you separate these two triangles and check the corresponding sides. So I'll draw the smaller triangle this side. This is E, this is D, this is C. And then the bigger triangle, they will always tell you the similar triangles. So this one is on top of the other triangle like this. So when you take it, when you remove it, then you remain with the bigger triangle, like this one here. So this is 6 centimeters. I'll just write the 6. This is 9 centimeters. I'll just write the 9. And then now BC is the distance from B to C. Remember, the distance from B to E is 3 centimeters, and then the distance of E to C is 9 centimeters. So now the total distance from B to C will simply be the sum of these two numbers, as you may have guessed. So BC will be 9 plus 3, which is a 12. Which other numbers do we have? None. So now to find the ratio DE to AB, all you need to do here is to check the other corresponding sides and then find their ratio. So since DE is from the smaller triangle to the bigger triangle, you just need to check two corresponding sides which have numbers on them. So in this case, as you can see, we have BC, which corresponds to EC. So I'm sure you can see that this one looks like this. It's like this is the smaller version of this. When you make this one small, when you diminish it like this, it becomes something like this. So to find this ratio, just start with the smaller triangle the way they did here. So you can say EC to BC, which is 9 to 12. So this is the ratio, except that you don't write your ratios like this. You want to reduce them as much as possible. So we still have a 3 which can go into both of these numbers without leaving any remainder. So 3 there will be 3, 3 there will be a 4. So since the ratio of EC to BC is 3 to 4, it means the ratio of ED to BA is also 3 to 4, and the ratio of DC to AC is equally 3 to 4. So that answers this question. DE to AB, which is DE to AB, will also be 3 to 4, and you are done. And then let's try this one out. By the way, I got each of these papers from past examination papers. So for this one, the similar triangles are this one here, PRQ, and P. I'm not sure what this one is. I think it's supposed to be, let me see, PT. This should have been a PT. So PT to PR. Yeah. So you can just separate these two triangles. It's much easier to see them in this manner. So the two similar triangles are this and this. Remember, they must both be triangles. A very common mistake is to remove this part and then remain with the trapezium like this. No, that's not what you want to do. You want to have two triangles which are alike, which are similar. They are almost the same, except that one is smaller than the other. So this is the bigger triangle, and then this is the smaller triangle. So now PR is 8, RQ is 12, and then this is supposed to be T actually. TQ is 3 centimeters, this one there. So now to find the ratio of PT, this one PT to PR, remember the ratios are always the same. So the ratio of PQ to PQ, what's this? This is supposed to be S. The ratio of PS to PQ is exactly the same as the ratio of TS to RS, which is exactly the same as PT to PR. Because these are similar figures and these sides are corresponding. This is the smaller version of this. This is the smaller version of this, and this is the smaller version of that. So to find the ratio of PT to PR, we can just pick any of the corresponding sides which have numbers on them. So we have TS to RQ there. So you can say TS is 3 to RQ, which is 12, and then you reduce it. You don't leave your ratios in this form. Make sure you write them in their simplest form. So this one will be a 1. When you divide it through by 3, this would be a 1, 2, 4, and you are done. Lastly, we have this one here. So when you separate these two, separating makes your work easier in that you can easily see the corresponding sides. If you don't separate them, make sure you are able to see the corresponding sides. If you can't, it's better to separate them. So AB is 2 centimeters. I'll just write it as 2. And then AC is the distance from A to C. So to get that distance from A to C, you need to add this distance to this distance. These drawings were not done to scale. So this plus this is 6. And then CD is 12. Nothing else here is known. Then we want to find the ratio of BE to CD. BE to CD. So to do that, just find other corresponding sides with known numbers. So I can't use AE to AD because I don't have numbers here, so I'll ignore this one. But I can use AB to AC because they both have numbers and they are corresponding. This is like the smaller version of this. So this ratio is the same as the ratio of AB to AC. And then AB is 2 centimeters. AC is 6 centimeters. When you reduce this, you have 1, 2, 3. This is after dividing through by 2. So this is how you solve such kinds of problems.